And now we come to example number 2, which is also quite straightforward, but I would strongly recommend you all to proceed with this calculation by using the given the given formula here: flow rate in the pipe and flow rate in the valve to solve these problems. So try to not to see the solution first before you attempt this one. Okay, but for this one, as we can see, a pressure difference of 1.1 psi, okay, be careful of this one, right, occurred across a constriction in a 5 centimeter diameter pipe. Okay, you have to take a look the important notes here. 1.1 psi, which is the pressure, the gas pressure, and 5 centimeter diameter is not radius. So we take a note of this value, and then the constriction constant is given here, which is K. The value of K is actually 0.009 meter cube per second per kPa. Okay, don't worry too much about the unit, but what most important here is 0.09. Okay, what you need to determine is actually the flow rate, okay, and the flow velocity. Okay, the question is flow rate and flow velocity. Okay, first we have to be able to identify these two formula between the flow rate, which is Q, and the flow velocity is actually V. And be careful of this one. And this question is asking for flow rate, which is Q, and the flow velocity is actually V. Alright. Okay. First, to solve the problem, we have to solve it ideally in the SI unit, as we already know. So the PSI, we must first convert the PSI into the Pascal. Okay, how you convert it is quite straightforward. For the 1.1 PSI times 6.895. This is the conversion. How to convert the PSI into the Pascal? So the value in PSI just simply multiply with 6.895. So that will convert the value in PSI into Pascal. In this case, we will get 7.5845 kilopascal. So this is the value of pressure difference. Okay, so by looking at this example or this formula, we already know the value of delta P here. Okay, and we know the value of K, which is the constant, the constriction constant, which is 0.09. Just plug in the values into this formula, will give you the flow rate. So very straightforward. Q is equal to K, the constant, times to the square root of delta pressure. Okay, so we'll give you 0.025 meter cube per second. Okay, make sure if you want to calculate, you need to write a correct, at least the final answer for your exam or test or anything should be correct. Okay, Q 0.025 meter cube per second. As what you can see here, they are written in the SI unit, so that is very clear. Okay, how to obtain the flow velocity? Flow velocity is also very simple. Come back to this one. Q is equal to A times V. So we already know Q. We can actually calculate A, and we can obtain the value of V. So here we plug in the values, and then that will give you 12.7 meter per second. Alright, not to forget how to calculate the area, the cross-sectional area of the pipeline. So they already given the value here, 5 centimeter. So you have to convert into meter. Okay, centimeter need to convert it into meter, SI unit, so that you will get the correct answer. Otherwise, you will end up with the wrong answer. So make sure to convert all the given data and parameter into the SI unit. Okay, this is also very straightforward. Please practice by yourself to see a common mistake that you may do. Right, so what most important in this example is actually to convert into the SI unit, PSI and the centimeter before perform the calculations. Okay, that's about it about the flow work example. And now we come to the next section, which is about the actuator, the one that I actually explained to you earlier. We have several type of actuator here, and then this is the additional. For example, you can see here the electric motor and solenoid. Okay, we can have the actuator. Okay, these are the manual valve. Okay, so you can control it manually here, and then this is a solenoid operated. Solenoid means we have a coil. We energize the coil with the current and voltage, and then that will induce the torque to pull the stem, to pull the valve. And then we have also piloted valve. There are various type of actuator, but the most common one is the maybe manual, and we can say as the solenoid, also as well as these three type: spring and diaphragm and motor control valve for heavy duty applications. And if we go very specific, we have example here about the construction design of a particular actuator. Okay, sometimes they are very complicated, like this one. We have example here. We have a valve, very small valve here, but maybe due to the its applications, we have a complicated actuator. Say we have even microprocessor control board, and then we have a proper aluminum housing, position indicator, sensors, and etc. So this is example of the complicated or actuator as compared to the spring and diaphragm. Okay, this is just example, don't worry. And then okay, now we come to the we look closer for the spring and diaphragms actuator, pneumatic actuator using IP. IP is current pressure converter. Okay, means that we convert we convert the current which is in the range of 4 to 20 milliamp to the pressure 3 to 15 psi. Right, so this is example, but you will learn this one in the next chapter about signal conditioning, so don't worry too much about that. How to integrate, how to convert current into the pressure. Okay, now we look into the spring and diaphragm actuator. As I mentioned to you earlier, is this one. Okay, we have air pressure, we have diaphragms, and then spring for to return the back to the diaphragm to the original. But in this example, as we can see, as we inject the air pressure will push down the diaphragm, and then this will lower the stem. Okay, that is the that is what involved here is the spring. Okay, spring constant. The characteristic of spring is characterized by the spring constant, and then the pressure obviously, and the surface area of the diaphragm. Alright, this is the controller. This is pneumatic. This is the signal conditioning, IP converter. Okay, IP converter. This is the one that control the diaphragm. Okay, this signal can be transmitted into various approach. One of them is actually through the sensors and signal conditioner approach. Alright, okay. What we can see here, we have a simple formula here, which is F. F is actually force or Newton, measured in Newton, is equal to A. A is actually diaphragm area. Okay, the area for the diaphragms, the space, and P, P1 minus P2 is actually the pressure difference. Means that measured in Pascal. Okay, diaphragm measured in written in the meter squared, and force is in Newton. Okay, so we have force is equal to A times pressure difference, delta P. That is one. Okay, number 2 is actually delta X. Okay, delta X is actually the shaft travel. Say we already pump in the gas inside here, and then that will shift the stem, the spring, either lower, up or down. So the distance of this shaft travel, we call it as delta X. In this case, it's delta X, and can be obtained, calculated by using the formula A, which is the diaphragm area again, divided by spring constant, which is K. Okay, spring constant, Newton meter. This is a characteristic of the constant. Where how to obtain this value? Definitely will be given in the data sheet. And times delta P, which is the pressure difference. Okay, so we have two important formula here to further understand the spring and diaphragm working principle and functionality. Okay, now we come to this example 3. Okay, example 3. Okay, suppose a force of 400 Newton must be applied to a valve. Okay, 400 Newton to be applied for a valve. Find the diaphragm area if the control gauge pressure of 70 kPa, kilopascal. Okay, remember if the value is given in PSI, you need to convert to the Pascal first, then only you can use the for the calculation. Okay, it's very straightforward. Must provide this force. Okay, must provide this force. Okay, so come back to this formula. Okay, what value given is actually here 400 newtons, and then we have the pressure difference. So they asked to calculate the diaphragm area. Okay, so come back to this formula. Okay, we have we can use this formula. We have the pressure difference is given, the force is given, so we can actually calculate the diaphragm area. It's very straightforward. Plug in the values and will give you, for example here, in term of A, so the area is actually 5.71 meter squared. Okay, this is the area. If the question want to trap you, maybe they will ask further what is the radius. So you have to know the formula how to convert into radius, which is we can use this one, right? A for the circle, so area, cross sectional area for a circle. Alright, so if you convert to, and you can also specify in terms of here 8 equal to 8.5 diameter. So but the question is asking about the area, so the answer is in meter squared. If they ask about diameter, will be 8.5. If the question asks about radius, should be 4.25 divided by 2 meter. So a very simple formula and very straightforward problems. It's just a matter for you to be able how to use and to be not to be manipulated by the questions. Make sure you get it right. And now example 4. Okay, example 4, a force of 400 Newton is required to fully open the valve that is equipped with pneumatic diaphragm valve actuator. Okay, they clearly mention here because previously the one that I've shown you here in this one is actually spring and diaphragm. Okay, we have diaphragm, we have spring. That's why we call it spring and diaphragm. But in this case, in this work example, it clearly mentioned pneumatic diaphragm. Okay, means that we have a diaphragm, and the way how we're going to use to shift the diaphragm is by using the pneumatic. Pneumatic is something related to pressure, gas pressure, right? Gas pressure. So the valve control, the valve input control signal for the actuator has a range of 20 to 100 kilopascal. Okay, watch out for this value given. Calculate the diaphragm area that is required to fully open the valve. Okay, the question is to fully open. Okay, the keyword here is to fully open. When fully open, we are talking about the maximum pressure difference. Okay, don't worry about the pressure difference, but we go for the maximum, because it says here to fully open means that the pressure difference need to be maximum. Okay, how to answer that? Okay, force is actually calculate the diaphragm area. Again, we're going to use the same formula that been given earlier here. F equal to A times pressure difference. And then for A, in this case, is 400 newtons divided by 100 kilopascal. So 1 times to the power or 10 to the power of 5 will give you 4 times to the power of 10 meter squared. 10 minus 3 meter squared. So this is the answer given in the SI unit. Okay, not to confuse yourself. In this case, they just simply use the maximum value because it's fully open. So if they're asking about at the minimum is not open or closed, for example, it's something to do with 20 kilopascal here. Okay, but in this case, it's fully open, so we refer to the maximum value. So that's why we use 1 time to the power of, which is we use the 100 kilopascal. If written in the SI unit, will give you this one. Okay, I think that is more or less about the how we going to example how to use this formula. Okay, 1 and 2. So for the next topic, okay, this is about the summary or a brief description about the actuator advantage and disadvantage as I explained earlier. Okay, spring and diaphragm, as we can predict. Okay, lowest cost because it just involve the diaphragm and spring. Ability to throttle without positioner. Okay, dia tak perlu pun positioner. It doesn't really require the positioner. Simple construction design. Inherent failure mode, low supply pressure requirement. Okay, since we are talking about the spring, that's why we don't really need the high pressure gas or pneumatic requirement. Okay, when you talk about the heavy duty equipment, that may need the pneumatic or hydraulic for heavy duty work, easy for maintenance. Okay, since it just involve the spring, it just involve the diaphragm, it doesn't really require to calibrate much. Say for example the motor, which required you to grease here and there, the gear and etc. Okay, but not to forget some of the disadvantage. Obviously, since it is very simple and it has a very limited output capability, and sometimes because it involve the diaphragm, this will consume space, means that the size and the weight could be high. Right? Okay, you can read by yourself all these advantage and disadvantage, and then make sure you should be able to do a simple comparison or try to understand what are the differences between one type of actuator and to the other. Okay, so this one high pressure spring, obviously high pressure, we are talking about compact and light because they are compressed the spring into a smaller size. That's why they call it high pressure spring. And then you can read the rest. And then pneumatic piston. Okay, a pneumatic piston, this one is pneumatic, is compact, lightweight, high force. Okay, because we are talking about pneumatic, that obviously require a very high gas pressure. That's why we call it pneumatic. And then that will reduce the size, but the disadvantage part, safety requirement, positioner, higher cost, higher supply, and we also have electric motor and hydraulic. You can read by yourself all of this and should be able to make a simple comparison between all of this type of actuator. The reason I would encourage you to do a simple study is because for you to understand, to really understand the problem, to really understand the working principle of this one, and to synthesize easily in mind, if you are talking about the advantage and disadvantage of a certain actuator, you should be able quickly recall what is that without without referring to the notes and even to the textbook. That should actually come to your mind instantly. That is my intention. I think that's all for this second this topic. I'll okay, for the next chapter, we are going to talk about the valve characteristic in the next video. Thank you. Assalamualaikum warahmatullahi wabarakatuh.